There are 4 runners on the new high school team. The team is planning to participate in a race in which each runner runs a mile. The team time is the sum of the individual times for the 4 runners, so it's a relay. Assume the individual times of the 4 runners are all independent of each other. I guess it's not a relay. The individual times and minutes of the runners in similar races are approximately normally distributed with the following means and standard deviations. These are fast. 4.9 minutes per mile. With a standard deviation of 0.15. Runner 2 is 4.7, standard deviation of 0.16. Runner 3 runs a mile in 4.5 minutes with a standard deviation of 0.14. And then a runner 4 runs a mile in 4.8 minutes with a standard deviation of 0.15. Runner 3 thinks that he can run a mile in less than 4.2 minutes in the next race. Is this likely to happen? Explain. Okay, so this is a normal CDF problem, right? Here's runner 3. His average time is 4.5. It has a standard deviation of 0.14. What's the probability that his running time is less than 4.2 minutes? So we just go into our calculator and find the probability that the running time is less than 4.2 minutes. And it says that they're all normally distributed in here, so we don't have to justify the fact that we're using a normal CDF to do that. So, all right, so we get our calculator. So, there you go. Probability is 0.016. So that means it's possible. You know, he's got a 1.6% chance of pulling it off based on this, but, you know, it's not very likely. And there you go. The distribution of possible team times is approximately normal. What are the mean and standard deviation of this distribution? So now what they want is they want the distribution of the entire team, not just each individual racer. So the first part of this is easy. So for the mean, for the combined distribution, all you have to do is add these means together. So all you have to do now is say, all right, well, 4.9 plus 4.7 plus 4.5 plus 4.8 equals the new mean time. And there you go for the mean. For the standard deviation, remember, you don't actually add the standard deviations together, you add the variances together, and then take the square root of that to get the new standard deviation. So basically what you're looking for is the square root of the square of each of these. So remember, it's the square root of the sum of the variances. You can't add the standard deviations, you have to add the variances, which of course are just the standard deviation squared. So there you go. And you can do that in the calculator as well. You don't have to do it by hand. I just, you know, you don't need me to show you how to add numbers together in a calculator, right? Suppose the team's best race time to date is 18.4 minutes. What is the probability that the team will beat its own best time in the next race? So now this is basically part A, but instead of using 4.5, 0.14, and 4.2, we're using the new team, the team's mean time, 18.9, the team's standard deviation of 0.3003, and the new goal of 18.4. So we just get our calculator. You know, again, it's a normal CDF, so and there you go. There's the probability for that. So again, it's possible, but it's not very likely, but we just have to record that probability. And there, all done.